Hi everyone, today we are going to talk about solving a system of equations by using a method called substitution. Remember, a system of equations has two or more equations, and they each have two variables, or well, one or two variables. So what we're going to do is first give a definition of substitution. What do you think substitution means? If you have a substitute at school, that means that your teacher is being replaced for the day. And so substitution means that we are going to replace, if I can get my pen to work, we are going to replace the variable with a number or a constant and solve. And so if you look at example number 1, it says if x, negative 3 is a solution to 2x plus 3y equals negative 11, what is the value of x? Well, now let's think about this just for a minute. What kind of item is this? It's a point, that's right. It is a point. And the x is visible. You can see the letter x. But the y has been replaced by a negative 3. And so if you look at this is a linear equation because remember you can take and solve for y on this, but we're not going to do that. We want to just take that negative 3 and put it in place of the y because it's the x that we don't know. So we're going to put that negative 3 right there. So we'll do 2x plus 3. And remember that when there's a number and a letter next to each other, that means multiply. So in place of the y, we're going to put a negative 3. And then that's going to equal negative 11. Now remember, we're going to replace the variable with a number and solve. What do you think we're solving for? That's right, we're solving for x. It's asking what is the value of x. So as we look at this, we need to simplify a little bit first. 3 times negative 3 is a negative 9. We'll just drop that negative 11 and we'll drop the 2x. And then we've got 2x minus 9 equals negative 11. Now our goal, remember, is to get the x by itself. So that means we need to take that minus 9 and add it. So we have 2x is equal to a negative 2. And so now we've got to get the x by itself by dividing by 2, and x is equal to negative 1. So that is the value of x. So the point negative 1, negative 3 is a solution to that linear equation. So x equals negative 1. Next we're going to talk about the solution to a system when we're doing a substitution problem. Now the solution to a system is still the point of intersection. Even if we solve the system by doing substitution, we're still going to get a point of intersection. And so remember, you can have 3 possible solutions. One solution would be no solution. What kinds of lines make no solution? Parallel lines. Very good. And you'll see that it's going to be a little bit different in the way that it looks on today's lesson, but you've seen it before. And number 2 is going to be one solution. And remember, one solution is labeled with an x and a y. And then number 3 is an infinite amount of solutions. Infinite solutions. And again, this is where you have the exact same line, but you'll see on the notes today how that will look. And again, you have seen it before. The next part, it says, let's make a sub sandwich. So this is just kind of a little strategy to help you remember how to do substitution with systems of equations. So we're going to make a sub sandwich. And just as you would imagine, a sandwich has bread. Well, that bread is going to be considered the equation that is already solved for the single variable. We are going to look for an equation that is solved already for the single variable, or it could easily be solved if we don't have one. but we're going to hope that every time we're able to find an equation that has a single variable, that means a variable that's by itself already. So as we look at this next example and we see two equations, remember a system of equations is two equations. Do we see one that has a single variable? Yes, this variable is all by itself. So this one is a single variable, and we're going to call this the bread, and we're going to put x equals 3y here, and we're also going to put the x equals 3y over here, because remember a sandwich has bread, then meat, then bread. So the single variable gets to be in the bread column, and we're going to put the other equation into the meat column. And just as we did on example number 1, we need to find something to substitute. Well, if we have a single variable, that x, and it tells you exactly what's equal to that x, we're saying that 3y is the same thing as x. Well, in the meat column, you see an x right here. So what we're going to do is we're going to replace, we're going to take out the x that we know, and we're going to replace it with 3y. So we see negative parentheses 3y, because remember when we substitute it's best to put parentheses. Then we write down minus 2y equals 46. So whatever the bread is, we find the bread over here in the meat column, and we replace it with what is equal to it. Now, we've got negative 3y, because negative times 3y is just negative 3y. And if we look at the left-hand side, is there anything that can be combined? Absolutely. These 3y, the 3y and the negative 2y can be combined. And using your integer rules, it's negative 5y for negative 3y plus negative 2y. And we end up with 46 over here. And so we need to make a little correction here. Let's make this a 5 here. We'll make each one of these a 5, make it 45, and that way that is not going to come out to be a nasty fraction. So we're going to go ahead and make that a 45. My apologies. So when we solve for y, we're going to divide by negative 5 on both sides. And when we do this, y is equal to a negative 9. Now, what we need to do at this point is we need to take this negative 9 and put it into our solution, because remember we have an x and we have a y. So we put a negative 9 in for the y. Now we need to figure out what the x is. Anybody have any ideas? Well, that's right. You know that y is equal to negative 9, and over here in the bread column you have what x equals. It equals 3 times y. So all we have to do is take this negative 9 and go up here and put it where the y is. So we have x equals 3 times negative 9, and x equals negative 27 would be your answer for the x. And so now your solution is one solution. It's got negative 27 for the x and negative 9 for the y. So we're taking whatever the bread is equal to, and we're substituting it in for the bread, and we're solving. Once we get that number, then we take and put it back in the bread column, the second bread column, and we solve for the other letter. Let's try another. As we look at example number 3, we have 4x minus 3y is equal to 9, and y equals x minus 2. Which one is the bread? That's right, the one with the single variable. So we're going to do y equals x minus 2 in the bread column, in both bread columns. And we'll put the 4x minus 3y equals 9 in the meat column. So now remember, in order to solve this, you're going to take whatever the bread is equal to, and you're going to circle it, and you're going to put it in place of the bread letter. So we're going to start out by doing 4x minus 3, and remember this is being multiplied, so we're going to do parentheses, x minus 2, and that's equal to 9. Now we've got to simplify this, and on the left-hand side I see parentheses, so I need to multiply negative 3 times x, that's negative 3x, and negative 3 times negative 2 is plus 6, and then we'll bring down the 4x and we'll bring down the 9. Now we need to combine like terms over here. The 4x and the negative 3x go together, so that's 1x plus 6 equals 9. Now again, our goal is to get the x by itself here because we plugged in for the y. And so we're going to subtract 6 on both sides, and so x is equal to 3. Well, we can go ahead and put that into our solution in the x place. Remember, put it in the x place. And then we need to take that 3 and go into our next column, but where are we going to put it? We're going to put it in for the x, that's right. Y equals 3 minus 2, and 3 minus 2 is 1. So our solution for this system of equations is 3, 1. Let's look at the next one. On this example, we see 4y equals 12x minus 4 and y equals 3x minus 5. What's the bread? The bread's the single variable. Y equals 3x minus 5. Put that in both bread columns. Then put your meat in the middle column. Take whatever your bread is equal to and plug it in for the bread. You've got y equals, so we're putting it in for the y. So we do 4 parentheses, 3x minus 5, we're multiplying. And then we've got an equals 12x minus 4. Now remember, we've got to simplify those parentheses. We don't want those there. So we're going to distribute. We've got 12x and negative 20. But wait a minute, we've got variables on both sides. What we need to do is get the variables all to one side. So I'm going to subtract 12x from both sides. And we have negative 20 is equal to negative 4. Do you remember when we had variables on both sides and the variables canceled out? We've done this before. And what happened here? It ended up giving you something that's false. What's the answer when you get something that's false? It's no solution. So this one we don't even need to go and try to substitute anything in because we're done. We can't go any farther. The solution to this one is no solution. What does that mean for our lines, do you think? What do you think those lines are then? If it's got no solution, they're not ever going to intersect, what kinds of lines would those be? Those would end up being parallel lines. So if we were to solve this one for y equals, we would end up with parallel lines. Let's look at the last one. Again, we look for the one that has a single variable, that's here. So we're going to put that in the bread column. We'll put it in both bread columns. And we will put this into the meat column. We'll take what the bread is equal to, and we'll plug it in for the bread. So we have 3x plus 3 times negative x plus 4 equals 12. And again, our goal is to get the x by itself, but we've got parentheses we got to get rid of. So 3 times negative x is negative 3x, and 3 times 4 is 12. If we bring everything else down, then we combine like terms. 3x minus 3x, well, those go away. And so all we're left with is 12 equals 12. And again, the variables have gone away. So what do we need to do? We need to think, okay, is that true or false? That is true. And when you have a true statement, what is your answer? All real numbers. So let's think back. If we had all real numbers, remember we did this on the first set of notes, if we had all real numbers, then what does that mean that our lines are? The exact same. So if we were to solve this equation right here for y, you would see that they would be the exact same equation. You guys did a great job making sub sandwiches today. Have a great day.